Okay, so today's discussion will center on the brain and the sensory system. The brain and the sensory system. So first, we need to know what sensation and perception is all about. Sensation and perception.
Princess guys.
Okay, so we need to know what sensation and perception is all about. So within your slice, um, sensation and perception has been defined. And basically what we are trying to say is that with sensation, you sense certain information within your environment. And I believe back in lower primary and so on and so forth, or even JHS, you were exposed to the sense organs. So it means we have five sense organs, and these organs are the ones that picks information from the environment. And when that happens, then it means sensation has taken place. Then afterwards, those information will be sent to the brain for interpretation. So when it is sent to the brain for interpretation, and interpretation has been done, then we call it perception. So for instance, for you to see information within your environment, or for you to see that, oh, this color is what is blue or white, it means that your eyes will pick that kind of information as light rays. And these light rays are then what forwarded to the brain for interpretation. So that those light rays will be integrated and organized within the brain. Then out of it, interpretation will come and let you know that, oh, this is what color blue. And when that happens, then it means perception has taken place. All right. So with sensation and perception, when it comes to this course, we'll focus our attention on the eyes and the ears. Our focus will be on the eyes and the ears, not all the five sense organs. How information is processed within the eyes and the ears, and it is also processed within the brain. So we'll draw a link how information is processed within the eyes, then later it is moved to the brain for interpretation. Then the same thing for auditory information, ears. All right. So in most situations, there's more or less like a diagram of how sensation and perception is processed. So it means the information is within the environment. So light rays or sound or smell. So if it is light rays, then it means that the eyes will be the one to pick the information. So the eyes picks the information, sends them, process it, then it is moved to the brain for it to be interpreted. And the same thing applies to the other stimulus energy. So it means that one thing you should know is that if the information is light rays, it will be processed by a specific brain portion. Whereas if it is sound, it will be processed or interpreted by different brain area. So that's where loss of specific energies comes into play. It is telling us that when information is picked by our sense organ, it is what? It is perceived by different what? Nerves within the brain. All right. So I wouldn't spend too much time when in discussing the structure of the eye because you have detailed information within your slides, and this is self-explanatory. This is self-explanatory. So it means that with the structure of the eye, These are the things you need to know: the cornea, lens, iris, then pupil, retina, rods, and cones. So with the retina, within the retina, we have these structures, the rods and the cones. So during night, it means that your rods are very active, because when you find yourself in dark places, the rods are activated to help you to see certain information. Then during daytime, the cones are much more active. They are active. So within your slides, your lecturer gave you pointers when it comes to differences between the rods and the cones, and these things are self-explanatory. So my main focus will be on information from the eye to the brain. So, after you pick information from the environment, first, it will go through several stages, okay, within the eyes. So from the cornea, okay, then to the pupil, then it will be projected to the retina. So if it is daytime, it means that the cornea, sorry, if it is daytime, then it means that the cones will be the one that will be activated. Okay. Then afterwards, with time, that kind of information will be projected to the optic nerve. The optic nerve, which is around this area. Let me try and annotate. The optic nerve, which is this structure. Sorry, this structure. Okay, to be projected onto the optic nerve, and the optic nerve will be the one that will send the information to the brain region for further perception. And for information to move to the brain region, something happens. I told you the information from the environment, they are more or less like what? Light rays. So they are light. For it to move into the brain, it wouldn't go as light energy. It has to be converted. So it will be converted into chemical energy. And when that happens, we normally say that transduction has taken place. I think within your slides you can find it. Yes, exactly. So this is transduction. So transduction simply means that the light rays, okay, or the light energy is converted into chemical energy. So it means that information going to the brain is more or less like what? Chemical energy. All right. So please, any question so far? So first, this is what you need to know. Then afterwards, I would move the gear to second gear. So if you have any question, please let me know before I move further. Any question? If you have a question,
Yes, sir.
okay. So please,
Yeah.
you can go ahead.
Okay. My question has to do with the blind man. Since they don't have eye to pick from the environment, how do they perceive some information?
Yeah, we'll come to that. I totally get your
Okay.
question. Yeah. All right. So let me go ahead. So it means that, sorry, let me stop sharing this. Normally It's quite scanty. And share something that I drafted. So remember I said the optic nerve, that's where the optic nerve will be the one to send the electrochemical energy to the brain. Okay. So for it to, the moment, the first region of the brain that will receive this information is the optic kaizen. Okay. The optic kaizen is an X shape. So let me project it so that you know. Optic kaizen. Where can I find you? Oh, wow. Oh, sorry. It seems I didn't. Wow. So it is an X shape. You can Google it. You get a diagram of it. It is found at the base of the brain. So it is an X shape, and it performs similar role like the pons or the pons. So let me throw this question to the class. What's the function of the pons? The main function of the pons. We've done this a long time ago, brain and behavior. So I think these things should be on your fingertips. So please, if you know the answer, you can use the emoji to raise up your hand, then I'll call you. Wow, nobody has. Okay, Godwin.
Sir, it serves as a bridge between information from the medulla and
Okay,
the cerebrum.
okay. Apart from that, what other
And then
functions?
it is also responsible for projecting contralateral information.
Okay, so that's the key thing that I want. Remember, I said with the phones, it ensures that information from our right side of the body is what? Is moved to the opposite part of the brain. That's the left part of what of the brain, then vice versa. So it means that the optic kaizen would ensure that the visual information from our right visual field will be moved to the left part of the brain for perception. Then if the visual information coming is from the left part of the eye, it will then move to the right part of the brain for interpretation or for perception. So that's the function of the optic kaizen. All right. So when the optic kaizen projects the information to the opposite side of the brain, okay, it will then first hit the thalamus. It will then first hit the thalamus. And right now, again, let me ask the class, what's the function of the thalamus? The function of the thalamus, what's the function? Hello. Okay, Godwin,
Yes,
please
sir.
go ahead.
Okay, the thalamus, as I say, it is the junction at which all the sensory information from our sensory organs,
Good.
they are registered in the thalamus before it is distributed to the appropriate part of the brain, which are responsible for translating or interpreting those informations.
Thank you,
Except,
Godwin.
yeah,
Except,
except auditory information.
no,
Which
that's olfactory information.
Oh,
Smell.
sorry,
Yeah.
olfactory. olfactory information. Yeah,
Okay.
For olfactory information, it passes through the olfactory bulb.
Good. Yeah, you're right. Thank you. So
Welcome, sir.
All right. Johnson, please, your hand is up. Johnson, sorry, I could barely hear you. So if you have any question, please go to the chat room section and type. Okay. So as Godwin Riley said, we normally say that the thalamus is the relay station, meaning that it projects sensory information to the higher cortex. Okay. So it means the moment the optic kaizen moves the information to the thalamus, we have a specific area in the thalamus solely for vision, and we call it lateral geniculate nucleus. So per the slides that I've projected up, holding it so that you know what the lateral geniculate nucleus is, and even the spelling. That's LGN. So the lateral geniculate nucleus can be found within the thalamus. And that's what the structure that will project the information to the higher regions. All right. And the main area the information will move to is what is referred to as the primary visual cortex. And we've already talked about this during brain and behavior. So again, what's the function of primary visual cortex? And I give you about 3 names when it comes to it. So what's the function of the primary visual cortex? So please, let's be snappy about this because we already have information when it comes to this. Godwin again, please go ahead.
But it is responsible for conscious vision.
Yeah, responsible for conscious vision. So it means for you to perceive, maybe I don't know the gadget that you are using. So let's say you are using a laptop at the moment. You being able to see that, okay, this is a laptop. Okay, these are the processes it goes through. So first, the retina will move it to the optic nerve, where it will be transduced. That means it will be converted from light energy to electrochemical energy. Then the electrochemical energy will move to the brain. And the first brain region it will hit on is the optic kaizen. And I said the optic kaizen is an X shape found at the base of the brain. So the optic kaizen will make sure that if the information was what was picked by the right eye, the optic kaizen would project this information to the left part of the brain. So that means the left thalamus will be the one to pick that kind of information. And within the thalamus, we have a specific region solely for visual information. It processes only visual information within the thalamus, and we call it lateral geniculate nucleus. So the lateral geniculate nucleus will then relay the information to the primary visual cortex, also known as straight cortex or area V1, found within the occipital lobe. So the moment the area V1 receives the information, it will then process it for you to see it as maybe laptop or a phone. That's for perception. So perception will then take place. So these are the neural mechanisms that happens. All right. So please, any question? Any question when it comes to this information from moving from the eye to the brain? Any question? Emmanuel, the third is please, if you have a question, it's better if you use the emoji to raise up your hand. So Emmanuel, you've unmuted yourself. Do you have a question? Emmanuel, hello.
Uh-huh.
Do you have a question? Emmanuel, sorry, I could hardly hear you.
Okay. Like what I want to say.
Okay, please go ahead.
Yes, sir.
Yes, I can hear you. Go ahead.
So this explanation.
Emmanuel. Sorry, Emmanuel, if you have a question, kindly go to the chat room section and type out the read. So Vivian, you at the chat room section, you indicated which section are we treating? Wow, it's session 7. That's the brain and sensory system. All right. So please, any other question? Okay. Meaning I can continue. So someone asked, why is it that if someone is blind, they can still perceive certain information? That's a typical case known as the blind sight phenomenon. Okay. So what I have here, we are saying that with the blind sight phenomenon, it shows that even when the primary visual cortex, and right now I know what the primary visual cortex is, when it is damaged or removed, a person can still perform actions guided by unconscious visual information. So it means that we know the area V1, it functions as what? As conscious vision. It helps us to see things. But if you see that if someone is blind, sometimes, the person wouldn't see you all right, but the person can sense that, someone is here in my presence. So in most situations, they use something known as motion, especially to do that. And when it comes to motion, it is not processed by the area V1 or the primary visual cortex. So since the other region responsible for motion or responsible for processing of information is intact, it means that definitely the person can still perceive. So this time around, the person is not using his or her area V1 to see that, okay, this is what is happening, but there's motion happening, movement. So definitely they can sense that, someone is really closer. So within the brain, the main region responsible for motion perception is middle temporal visual area. And sometimes the temporal lobe also plays a role in motion. So since these regions are intact, it's not damaged, definitely the person can still perceive. All right, Cyril, your hand is up. So please, I'm not using the premium Zoom. So Zoom just alerted me that I have less than 10 minutes. So when it cuts, kindly use the same link to join. Cyril, please go ahead. Cyril. Please, I can't hear you. You've unmuted yourself, all right, but I can't hear whatever you're saying.
Why is it from
my end or something? Or
No, sir, we cannot hear him either.
oh, okay, then let me go ahead. So that's the answer to the person who asked why someone who is blind could also sense certain information. Yeah. Cyril, your hand is up again. You can unmute yourself if the mic is okay. You're able to resolve it. You can unmute yourself and speak. Sorry, Cyril, we can't hear you still. All right. So within the visual processing, we have two main pathways. We have two main pathways that you need to know. Two main pathways. The first pathway is the ventral pathway. The ventral pathway. So with the ventral pathway, what this implies is that when the information gets to the area V1 found at the occipital lobe, in some instances, that information further moves to the temporal lobe for perception. And there are certain information that are communicated by both the occipital lobe and the temporal lobe. So for instance, if you want to recognize the shape of maybe the laptop or the phone that you are using. So for you to know that, oh, this laptop is rectangular in shape and use other cues and all that, it is big. That means that sort of information needs to move to the area V1 and further move to the temporal lobe for you to recognize that, oh, this is a laptop. Also, for you to recognize a familiar face, you have colleagues. Okay, so for you to recognize that, oh, you've seen the person. Right now, we are having Zoom sessions. So it could be that some of your colleagues, they've switched on their video or they have pictures. So for you to recognize that, oh, this person is so and so, this person is Abigail. Okay, you could see that, oh, you use her face to do that. So for you to recognize her face and know that, oh, this is Abigail, it means it needs to go to the area V1 and further move to the temporal lobe for you to have these perceptions. So let me use diagram to do it so that you get it better. Yeah. So first, this is the eye. So let's say the information went to the area V1, which can be found around the side. This is the occipital lobe. Okay. So the area V1 can be found around the side. So if the person wants to recognize, or the person was trying to recognize, oh, a familiar face, this pathway doesn't just end at the area V1. So please try and mute yourself. It further moves to the temporal lobe, and this is the temporal lobe. This area is the temporal lobe. So it further moves to the temporal lobe so that the person can easily recognize the object or the face of the person. Okay, so when that happens, then we call it a pathway. They are lines. So we call the pathway ventral pathway. All right. So please, any question when it comes to the ventral pathway? Any question? Please, if you have a question, kindly use, it's better if you use the emoji to raise up your hand, because or else most of you would unmute yourself, then there will be this distractions. Okay, so please, Power.
Please, my question is with the hello.
Yes, I can hear you. Please go ahead.
With the damage of the temporal lobe, can it happen that a person will be able to recognize shapes but unable to recognize faces?
Good. So we have a typical disorder for that. Sometimes we call it face blindness, or we use a technical name known as prosopagnosia. So it means when there's a damage within the temporal lobe, okay, then it means the moment information gets to the area V1, it wouldn't be able to go to where to the area within the temporal lobe for recognition. It wouldn't be able to what? It wouldn't be able to process that.
Okay.
So it will lead to this disorder, prosopagnosia, whereby the person wouldn't be able to recognize familiar faces. So some of these prosopagnosia patients, they can't even recognize their own face. It goes beyond. Yeah, that. So,
thank you.
You're welcome. So in neuropsych test, this is what we do. It could be that when you ask the person who is the president of maybe we are in Ghana, ask the person who is the president of Ghana, the person can tell you that currently the president is President Manado Dankwa Ekufuado. Fine. But the moment you show a picture of the president, the person wouldn't be able to recognize that, okay, this picture is President Ekufuado. And in most situations, in doing such tests, this is how we show them the picture. You don't show a full picture of the person to the client. Why do you think? I just want to find out. Daniel, I'll come to you. I know your hand is up. I'll come to you. So why do you think we don't show a full picture of the client, or a full picture of the person to the client? Any idea? Okay, but you've unmuted yourself. Okay.
Yes, maybe you want to the face to focus much on the face rather than the other part of the head.
Okay. Nice try. Nicholas.
Yes,